Hello. In this video, I will be covering doubly linked list and general list in C++, continuing our journey through fundamental data structures. So first, what is a doubly linked list? A doubly linked list, or DLL, is similar to a singly linked list, but each node has data, a pointer to the next node, and a pointer to the previous node. This allows traversal in both directions. So let's look at our basic node structure. So in this file, you can see we have our struct called node. We have integer for the data. We have a node that is pointing to the next one and a node that is pointing towards the previous one. But now let us actually make a node here. So to create a single node, we're creating a node called node 1. That is a new node. We're going to assign the data to be 10, and then the next and the previous to be null pointer, because this is the only node in the doubly linked list. Then we're going to print out the data. We're going to delete node 1 and then return 0 for a successful execution. Again, we always delete at the end of our program to make sure that we are not leaking memory. So now that we understand this, let us compile and run our code. As we can see here, it prints out the node data to be 10. Our next example here is actually creating a doubly linked list. So we have our same struct node as the previous example, but here we are creating multiple nodes. So the head, we're going to assign that to be a new node. The second, that's going to be a new node. And then the third is going to be a new node. Next, we are going to assign data to the head, the second node, and the third node to be 10, 20, and 30 respectively. Next, we need to connect the nodes. So for the head, the next is going to be second, and the previous is going to be null pointer. The second node, the next is going to be the third, and then the previous is going to be the head. And then finally, the third, the next is going to be null pointer, and the previous is going to be second. Just as we did last time, we can demonstrate a forward traversal. So starting at the head and then working our way through. So while the current node is not null, we're going to print out the data and then change the current node to be the next one. And then we're going to make a new line. Again, the current represents what is next. And then on line 36, the iteration current.next, making that current, iterates the loop. So that's why we do not need a for loop. Now we can demonstrate backwards traversal. So starting at the third node, while the current is not null, we print out the data, but instead of going forward, we go backward using current.previous. And then once we're done, we must free our memory and then return 0 for a successful execution. So now that we understand that, let us compile and run our code. As we can see, first it demonstrates a forward traversal, 10, 20, 30, because the data, the head is 10, the second is 20, and then the third is 30. And then a backwards traversal. And then we end the program. Let us conclude our final example here to insert a node at the beginning. So again, we are defining our struct, data, next, and previous node pointer. And then inside our main, we're going to start with a single node. So we're going to make head called new node. We'll make the data 20, and then next and previous pointers to be null. Next, we're going to insert a new node at the beginning. So we're going to create a new node called new node. We're going to define the data to be 10. The pointer next is going to be the head, and then the previous is going to be null. After we do that, though, we need to assign the previous node for the head to be new node, and then finally the head to be the new node. So after insertion, we're going to just demonstrate a simple forward traversal, just like the last program. And then we're going to free our memory. So head.next is the original node now, and then head is the new node. And then we're going to return 0. So let us compile. And run our program. Sorry for the error. And then now we are demonstrating the forward traversal after insertion. So we both have our new head node as well as the original head node, being 10 and 20 respectively. So again, as a general overview again, each node connects both forward and backward. Forward traversal uses next. Backwards traversal uses prev or previous. And then this flexibility makes DLLs useful for bidirectional navigation. And again, with our last program here, updating both next and previous pointers is required for DLL insertions, and insertions and deletions are much more flexible than in singly linked list. Next, real quickly, let's bring up general list. A general list is a list where elements can themselves be list. So an example would be a list of 3 items, A, and then the second item would be a list itself of BC, and then the final item would be D. These can be represented using pointers to list, allowing nested structures. While not as common in basic C++ programming, the concept is foundational for recursive data structures like trees. So, some key takeaways. A doubly linked list extends singly linked list with prev or previous pointers. Traversal can happen both forward and backward, and insertions and deletions are easier and more flexible. General list or recursive list where elements can themselves be list, forming the basis for trees and advanced structures. If you found this tutorial helpful, do not forget to like, subscribe, turn on notifications, and leave a comment. Please reach out if you have any questions. Otherwise, thank you for watching and have a great day.